All right, another method to find the volumes of revolution is called the washer method. Sometimes you're not going to have a full disk. Sometimes when you are going to rotate something, you find that your rectangle that you're revolving is up in the air here somewhere. There's a picture of this on your notes to show you how to do this. So when you revolve this around the axis of revolution, you end up with, this is a very poorly drawn disk. Let's try this again. You end up with a washer. Hopefully you guys all know what washers are. But a washer is just a disk with a hole in it. Something like that. So if we're revolving it around this, we have a washer. Now, what we have is, if you, let's see if we can look at it a little bit better this way. When you have a washer, you have all this space here that's full, but then you have this empty hole in the middle. So when you want the volume, what you've got to do is take the total volume of the big one, so you've got your pi r squared h, and then minus, if you used a little r for this small part, you've got pi r squared h, like so. So what you have then is you've got the big cylinder, and then you take out the smaller cylinder, and it gives you your volume of a washer. And you can simplify this by saying pi h times the difference of the radiuses, the squares of the radius. So we're going to use this now instead of just the straight pi r squared h to add them up, because just like with disks, we're going to take little pieces and add them all up. So there's a formula there in the middle of your paper that will help you to see exactly how we do this with integration, adding up little parts. It's just like disks, it's just we've got a hole in our disks now. So let's look at the examples at the bottom of the page. Again, we're just going to set up these integrals because I trust at this point you know how to calculate out the integrals. So let's start with this. It says set up the integral but do not solve. For the solid of revolution bound by, we've got y equals 2x squared, y equals 0, and x equals 2. And the first part says we're going to rotate it about the x, or the y-axis, excuse me. So we set up here. We draw our picture. We're going from y equals 0 to x equals 2. So we've got x equals 2 here. And we've got this line, y equals 2x squared. Now I'm only going to draw in the first, or the one side of this, just because when I rotate it, then it'll take care of the other side. And it gets confusing if you start drawing in multiple sides. So we're going to rotate this about the y-axis, which is going to give us a solid part over here, so that when we draw in, remember you've got to be perpendicular to that axis of revolution. When we draw in our disk, we see that we don't actually cover all the part that we are looking for. We really only want this outer part. So we've got to make this inner ring here where we're not taking that volume. So what we do is we're going to look at, we're going here, so we're dy. We started at y equals 0, and here this is the point 2, 8. There we go. So we're going up to 8, from 0 to 8. And then we need to find the volume of each of these washers and add it all up. So we have our 0 to 8, and we know we're multiplying times pi. Remember, you can put the pi out front if you want. And we know we've got our height dy. So we just need to figure out what our radii are. So the outer one, we're going from the center here out. So our outer one is a constant, so our outer radius is 2, and then of course we square it. Pi r squared h gives us the volume of the big cylinder. And then our inner ring here, we're going to the function. So what we need is this function in terms of y, because we're using dy. So we have the inner ring radius squared, so that we're subtracting off that volume. And so here's our integral that we can solve fairly easily and get what this volume of revolution is going to be like. It's kind of like a bowl with the sides are straight down, and we want to find that volume. Now what happens if we use the same functions and this time we're going to go about the x-axis though. So we draw our picture in, and again we have the same picture. So here's our area that we're looking at, and we're going to rotate it this time though about the x-axis, so we end up with a little more an actual solid this time. So when we put in our disc, it actually is a disc. We don't have to use a washer, we don't have a hole here or anything, so we can just do it with the disc method. We're going from x equals 0 to x equals 2 of pi. Now what's my radius? My radius is from the center out to the function, so pi r squared, and then times their height. So here's the integral I would use to be able to find that. Again, I didn't need a washer, I just needed a disc. I can see that by drawing my picture. Now, what if we take these same functions again? And this time we rotate it along the line y equals 8. So we're going to draw this down here. We've got x equals 2, and the line y equals 8 we'll put in right here. And we know that this goes like this, and this is our area. So if we're going to revolve it around the line y equals 8, then we'll end up with something like this, which again gives us a washer, because remember we're perpendicular to the axis of rotation. And we draw in our washer. We see we've got this hole in the middle, so we need a hole in the middle of our disc, so it gives us a washer. So again, we need to figure out what our bounds are and everything. So we're using a dx washer here because the height is on the x-axis, and we're going from 0 to 2. So we have the integral from 0 to 2 of pi, and then we need to deal with our radii, and we've got our height. So pi r squared h. So we start with the big one. The big one, we're going from the center out. So the center, that is a constant, 8 squared. So the big radius is 8, so we have pi r squared h for the big cylinder. And then we need the little one. We go out to, from 8 out to the function. So we go from 8 out to the function, and then square that. So look at that for a second and see if you understand why that is as it is. Alright, so there's our function. Of course, you can integrate that and figure out what that is. Right now we're just dealing with setting them up. Alright, let's try one more. So we're going with the same functions again, except this time we're going to rotate it along x equals 2. So we've got our original here, and we're going to revolve it around x equals 2, which will give us this part here. So we draw this in and we see that we don't need a washer, we have a disk. So what are we doing? Well, we're doing y, so we're going to have dy, which means we need this in terms of y. So we're going to go from our y values are going from 0. We said this was at the point 2, 8. So we're going from 0 to 8 of pi r squared. Oh, sorry, that's not all of r, is it? What's our r? Right, 2 minus our function squared times dy, pi r squared h. Alright, so make sure you understand this, you have read this, looked at the examples in the book that use the washer method, and understand how that's related to the disk method. They're very similar, almost the same thing. As long as you know how to find the volume of a cylinder and how to add those up using integration, you should be good. Write down any questions you've got, and we'll go over this some more in class.